Hello and welcome to another of our MMU Q-Step video tutorials. Today we're going to be looking at testing for difference and in particular looking at T-Tests and ANOVAs. Testing for difference is a way of looking at the average score for your dependent variable for each category of your independent variable and seeing if there are significant differences between the categories. This requires your dependent variable to be scale and your independent variable to be categorical. So in this example, we might look at whether there are significant differences in the amount of fruit or veg people eat a day based on their dietary type. To see how we test for difference, let's look at another example. Here's poor Hector the monster, who's just been stood up for a date yet again. So he decides to ask his monster friends why he's so unlucky in love at the minute. Hector's friend suggests that aside from not putting his actual age down, she has another surefire way to get him more matches. Have a picture with him and a dog. Hector isn't so sure whether to believe his friend, so he decides to gather the relevant data to test the hypothesis that there will be a significant difference in number of matches between those who have photos with dogs in their profile and those that don't. Because our independent variable has two categories, we have to run a T-test in order to test our hypotheses. When looking at the results from our T-test, we want to look for the p-value, which is sometimes also labelled significance. If this value is below 0.05, which ours is here, then that means there's a significant difference between the means of the two groups. Even though we've already rejected the null hypothesis, we still want to look at the means to give our results more context. We see that profiles with photos of dogs have a higher average number of matches than those without, and we now know that this is a significant difference. So on the back of the T-test results, Hector asks a random man on the beach if he can take a photo with his dog. Hector is all set to upload his picture of him and the dog when his other friend chimes in and says that actually people prefer photos with cats instead. So they go back to gathering data about the average number of matches for profiles with dog photos, cat photos and neither. And they formulate the hypothesis that there will be a significant difference in number of matches depending on the type of animal in the profile, which is a two-tailed hypothesis. So when we want to test for difference when our independent variable has more than two categories, then we use an ANOVA rather than a T-test. Your ANOVA will compare between all of your categories, looking for significant differences in the mean between them. The ANOVA gives us a p-value, which if it is below 0.05, tells us to reject the null hypothesis as there are significant differences between the groups. However, to understand which groups are significantly different from each other, we have to run what is known as a post-hoc test. The post-hoc test compares between all the categories in your independent variable and tells you which significantly differ from one another. We find a significant difference in number of likes between profiles with dogs and profiles with neither cats nor dogs. We find the same when looking at cats versus neither dogs nor cats. But we find no significant difference between profiles with dogs and profiles with cats. So profiles with dogs and profiles with cats both had a higher number of matches than those profiles with photos of neither, and this difference was significant. However, while profiles with cats had slightly more matches on average than photos with dogs, this was not a significant difference. So for Hector, the results of the ANOVA mean he definitely should have a photo of a dog or a cat in his profile, but that it doesn't matter significantly which. It's worth remembering that the T-test and the ANOVA are based on a set of parametric assumptions around your data, and that if any of these assumptions are broken, then we must use their non-parametric equivalents. So we use the Mann-Whitney for independent variables with two categories and the Kruskal-Wallis for more than two categories. So hopefully you know a little bit more about why we test for difference and how to understand the results of these tests. Thanks for watching another of our MMU Q-Step video tutorials, and we'll see you next time.